Today we're going to look at something called the quadratic formula. So first, let's start with the warm-up. Factor and find the zeros, or the x-intercepts of the roots of y equals x squared plus 3x minus 4. We learned yesterday that if you factor this using a box and circle, that the zeros are the opposite of the factors. So let's try a box and circle here and factor. We have x squared, we have a 3x, we have a negative 4. We want to know what multiplies to negative 4x squared that adds to 3x. So we start with the negative 4. What are some things that multiply to negative 4? Well, we could do 4 and negative 1, and we have to check, do they add to 3? And they do. So if they do, we'll put the x's here, and we have our 4x and our negative 1x in either order in the corners. Then we get the outside of the box. So what multiplies to x squared? X and x. X times what is 4x? That's plus 4. X times what is negative 1x? That's negative 1. So here's the factored form, x plus 4, x minus 1. The zeros are when these equal 0. And we learned a zero product property says if one of these factors is 0, then when we multiply, the whole thing's 0. So we're going to say, all right, what makes x plus 4 equal 0? Well, that's negative 4. So here's one of the zeros, or they're also called x-intercepts or roots. We also could set this equal to 0, x minus 1, what makes this 0? And we would get x equals 1. So if we plug in either negative 4 or 1, we're going to get a 0 here, and those would be the roots or the zeros of our quadratic. If I were to sketch a picture of this, at negative 4 there'd be a 0, and at 1 there'd be a 0, and it'd be a quadratic that would look something like this. What if you were trying to solve a quadratic and it wasn't factorable? Example, a baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second at an angle 45 degrees with respect to the ground. The path of the ball is given by this quadratic. Draw a picture of the situation. All right, so here's 3 feet above the ground. You're going to hit the ball up, and it's going to go down. And we would be looking for the zeros of the graph. One would be positive, one would be negative. Would this be easy to factor? Well, think about putting that in a box and circle. It would be pretty tough to find something that would multiply to these two that add to 1. So the question is, how can we find the zeros, roots, or x-intercepts if a quadratic is not factorable? There's something called quadratic formula that we can plug into, and you can use that for any quadratic that's equal to 0, and it will give you the roots. So there's a song that you can sing to kind of help you memorize this.
Okay, we're recording.
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
All right, so if that helps you remember it, here's another one. Little girl.
Above the world so high, like a diamond in the sky. Twinkle, twinkle, little star, how I wonder what you are.
That's good.
Good job, Emily. What about the x equals?
X equals negative b.
Uh-huh.
X equals negative b plus or minus the square root, b squared minus 4ac, all over 2.
So if that helps you remember the formula, great, but here's what it looks like. So if you get a quadratic in general form where x squared is the highest power, and then x, and then the number by itself, the number next to the x squared is a, the number next to the x is a b, and the number by itself is c. And if this equals 0, we can plug into this quadratic formula, where x is opposite b, so the minus means opposite, so if it's positive, turn it negative, negative, turn it positive, plus or minus the square root of b squared minus 4ac all over 2a. And so this is what we're going to practice using today. Here are the steps. All of the terms should be on one side, and 0 should be on the other. Identify a, b, and c, and find the 3 chunks and solve. So let's take a look at how we would solve. Use quadratic formula to find the zeros of x squared plus 5x plus 6. So again, we know one method. We can factor, set each factor equal to 0, and solve. But let's solve using quadratic formula. So we have x squared plus 5x plus 6. Everything's on one side. This equals 0. Let's identify a, b, and c. A is the number next to the x squared. If there's not a number shown, we know that that's 1. B is the number next to the x. Here it's 5. And c is the number by itself, which is 6. Now we're going to plug into the formula. X equals opposite b. So since it's 5, we're going to make it negative 5. Plus or minus the square root of b squared, so 5 squared, minus 4 times a times c. A is 1. C is 6, all over 2a, so 2 times 1. And just to make sure that we're typing everything in right, what I plug in here, I'm going to use parentheses. So the 5 we plug in, I can put parentheses here, but I didn't. And the 1, the 6, and the 1. All right, now we're going to separate it into the 3 chunks. So this is to minimize any error, and this is how you'll show your work. You're going to show me what this number is. We have this number and this number. So the work that I want to see in your paper will look like this. X equals negative 5 plus or minus the square root. And this you should be able to type in your calculator just like you see it. 5 squared minus 4 times 1 times 6. When you do that, and maybe I'll show you what that looks like. It'll take a second for this to pop up. But again, you just type in the stuff underneath the square root sign. Don't do the square root yet. But I know this is 25 minus 24, but I'll show you what it looks like up here. Okay, so when you type that in, we'll type in the 5 squared minus the 4 parentheses the 1, the parentheses the 6. So just type it in just like we wrote it down. And we get a 1, because it's 25 minus 24, 1, all over 2 times 1, which is 2. So you will show your work by figuring out these 3 terms, those 3 numbers I want to see. Next step, we're going to solve by splitting it up. So here we're going to split it up into the plus and the minus. All right, let's draw this better. Okay, so the first one would be negative 5 plus the square root of 1, hit enter, divided by 2. And the second one is negative 5 minus the square root of 1, hit enter, divide by 2. So the first one, negative 5 plus the square root of 1, is 1, which is 1. Means negative 5 plus 1, which is negative 4. Negative 4 divided by 2 is negative 2. So here's one of the roots or the x-intercepts. The other one is negative 5 minus 1, so that's negative 6, divided by 2, which is negative 3. All right, so when we factor this right here, these are the zeros. When we factor, we use the quadratic formula. And if we were to graph this, our graph might look something like this. At negative 2, there would be a 0. And at negative 3, there would be a 0. And we would have a quadratic, so it would be a U-shaped graph. So this is another way to find the zeros besides factoring and finding the opposite of the factors. We can plug in a quadratic formula. All right, let's try the next one. Use quadratic formula to find the zeros of this quadratic. All right, so first up, identify A, B, and C. A is 1, B is 5, C is 3. Plug into your formula. I forgot my 3 here. X equals opposite B, so negative 5 again, plus or minus the square root of B squared. So 5 squared, I'll put parentheses with what I plug in. Minus 4AC. Excuse me. All of this over 2A. Oh, A is 1. Okay, you're going to separate these into chunks, so you're going to figure out these 3 things to show your work. So we have x equals negative 5, plus or minus. And again, when you type it in, you just can type it in just like you see it. So we have the 5 squared minus 4 times 1 times 3, or 3 times 1, was 3 times 1, 1 times 3. So that'll be the square root of 13 all over 2a, all over 2. Next step, we split it up and solve. So one of them will be negative 5 plus the square root of 13 over 2. And the other will be negative 5 minus the square root of 13 over 2. Now we can leave it like this. If you want to see what the decimal is, we can type that in. Negative 5 plus the square root of 13. Hit enter. Divide by 2. So it's about negative 0.7 if you round. And the other one would be negative 5 minus the square root of 13. Hit enter, divide by 2. So it's about negative 4.3. So this one, if we were to graph it or look at what the graph looked like, at negative 0.7 there'd be a 0, and negative 4.3 there'd be a 0, and you would have your quadratic. Okay, next example. Remember you need 0 on one side, so we have to get rid of this minus 7. So the first step before we use quadratic formula or identify a, b, and c is add 7 to each side. So here's your quadratic. 3x squared plus 10x plus 7 equals 0. Then you can find a, b, and c. So here a is 3, b is 10, c is 7. Plug into your formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Okay, find your 3 chunks here. So these are the numbers that I'll look for on your assignment. X equals negative 10 plus or minus the square root. We can type this in. 10 squared minus 4 times a times c. Okay, so that's 16 all over 2a. 3 times 2 is 6. All right, break it up and solve. So we have negative 10 plus, the square root of 16 is 4 over 6. And we have negative 10 minus 4 over 6. And so if we solve that, negative 10 plus 4, negative 10 plus 4, hit enter, divide by 6. Okay, so one of them is negative 1. So it's negative 1. And the other is, it'll be decimal, negative 14 divided by 6. So negative 2.3. So negative 14 over 6, which is negative 2.3 repeating. If you were to graph this, at 1 there'd be a 0. At negative 2.3 repeating, there'd be a 0, and your graph could look something like this. Okay. Last problem, let's start with where we began, that baseball problem. Where does the ball land? So here, we can put one side equal to 0. Let's find a, b, and c. A is the number next to the x. B is the number next, or a is the number next to the x squared. B is the number next to the x, in this case it's 1, and c is 3. Plug in your formula. X equals opposite b plus or minus the square root of b squared minus 4ac. So this will be negative 0.0032. C is 3 all over 2a. Okay, figure out your 3 chunks here. So let's do the first one first. 1 squared is 1 minus 4 times that negative 0.0032. Times 3. Okay, 1.0384. All over, we're going to take 2 times our negative 0.0, ooh, too many decimals. So negative 0.0064. And then split it up and solve it. So this one I'll just type right in the calculator. So the first one's negative 1. Let's do plus the square root of 1.0384. Hit enter. Divide by negative 0.0064. Forgot a 0 here. Okay, so one's about negative 2.97. And the other one should be the one we use, negative 1 minus the square root, 1.0384. Hit enter. Divide by negative 0.0064. All right. So we get 315.47. I'm going to double check that. I'm not sure if I typed that in right. Okay, so again it was negative 1 minus the square root of 1.0384. Hit enter. Divide by negative 0.0064. Okay. All right. So that would be the distance where the ball lands right here. So our answer 315. So if we take a look at what that picture looks like, again, we hit the ball, it goes up and it goes down, and the reason why one answer is negative is you hit from the height, not at 0. So here's where the starting value where you hit it. It goes up and then it goes down, and where it lands right here is 315.47 feet away from home plate. So today you're just going to practice using Pythagorean theorem. We'll spend more time on this. The one thing that you want to remember is you need 0 on one side, and so if you have problems where you don't have 0 on one side, get 0 on one side first before you plug in.